Hi guys, well today we're going to do our simple examples for Newton's law, and from the last lesson you remember that the force acting on an object is equal to the mass of that object times its acceleration, and the way that we'd written that down in the last lesson was F equals ma. Force equals mass times acceleration. So in your workbooks you should have a table which is missing a few values, and this lesson we're going to do those equations together and hopefully convince you that this is really simple but really useful information. So something I prepared here. Oops. Just like that. Okay, so you should have something similar in your workbook and you're missing certain parts of the table. So I've got a lamp here, it's kind of glaring, but that's okay. So what we have here at the top is net force in newtons. We have mass measured in kilograms. We have acceleration measured in meters squared, which is meters times seconds again. And we are missing a few values. So let's just remind ourselves. I'm going to write the equation up here. F equals ma. Okay, I know it's quite small, but F equals ma. So if this is F, this is m, and this is a, if I know two of those values, I can work out the third one. Okay, so let's do the first one. We have a net force of 10. We're pushing 10 newtons on something that weighs 2 kilograms. Let's just put that into our equation. F equals 10. So 10 equals m equals 2. So 10 equals 2, and we don't know acceleration, so 2 times a. Okay, one way we could write this is 2a equals 10. So how do we work out 1a? Well, a must equal 10 divided by 2. A equals 5. So the acceleration would be 5 meters squared. So if I use 10 newtons of force on an object that's 2 kilograms, it will have an acceleration of 5 meters squared. Okay, cool. Let's do the next one. Okay, so now we know F equals 20. So 20 equals m equals 2, and we don't know acceleration, so 2 times a. Same thing again, 2a equals 20. A therefore must be 20 divided by 2. A equals 10. And look what we have here. When we apply double the force on an object of 2, we double the acceleration because it's proportionately related to that. So that makes sense. We apply double the force on something that's 2, and we get double the acceleration. Nice one. Okay, let's do the next one. So we know F again. F is 20, so we do 20 equals m. This time it's 4. So we've increased the mass to 4, and we don't know a. So we're going to write that as 4a equals 20. So how do we work out what 1a is? Well, a, we divide both sides by 4, equals 20 divided by 4. 20 divided by 4 equals 5. Okay, so I'll write that here. So you can see here, when I apply double the force on something that is now double the mass, it is the same acceleration. Okay, it's all proportional. So it makes sense when I'm getting these answers. They make sense when I calculate it using F equals ma. They're all related to one another. Let's go here. Let's say we don't know the force of something. Let's say we have something that's 2 kilograms and we want it to go at 5 meters squared. Well, we don't know F, so we're going to just write F equals m, which is 2, times a, which is 5, F equals 10. So if we wanted to move an object, a 2 kilogram object, at 5 meters squared, we'd have to use 10 newtons of force. And we've actually already calculated that one up here. Okay, so that makes sense. So if we didn't have acceleration last time, now we didn't have force, but if you have two of those numbers, you can work out the third value. Okay, second last one. Let's say we don't know the mass, or what mass would something have to be to travel at 20 meters squared using 10 newtons of force. So we know F in this case, it's 10. We don't know m, so we just leave m there. And we know that the acceleration is 20. So what do we have here? Well, 20m equals 10. Divide both sides by 20 to get m on its own. M equals 10 divided by 20. M equals 10 divided by 20 is 0.5. So that's 0.5 kilograms. So if I apply 10 newtons of force to something that is 0.5, I don't need to put the units, I've got that at the top. Sorry. If I apply 10 newtons of force to something that is half a kilo, sorry, I keep writing kilo, then it will have an acceleration of 20 meters per second. Okay, and the last one, just do the last one together. Again, we don't know what the mass is, so we'll put it into this little equation. F equals ma, F equals 10, m we don't know, a is 10, 10m equals 10. We divide both sides by 10, so m equals 10 divided by 10. Anything over itself is always equal to 1. So the mass here is 1. Okay, so you can substitute in anything you want. If you now know how do we apply this in the real world, I got a rocket, I want to get into space, I know the mass, I know how fast it needs to go to get into space, how much force, how much fuel do I need to use to do that. So this is a really simple equation, but it can be used for quite complicated things. Hope that makes sense. Catch me in the Zoom, we'll do this together again if you need to, but hopefully that makes sense and fill in your own workbook. Thank you guys.